Imagine the silence of deep space, the kind of silence that has never known a human voice, never felt the brush of wind or the warmth of a sun's gentle kiss, only the endless, patient drift of time measured in billions of years. In that silence, something moves. Not a planet, not a moon, not even a star, just a frozen relic, a wanderer older than Earth itself, hurtling through the void at a speed that would make your heart stop if you could feel it. This is 3I/ATLAS, the third confirmed interstellar comet, and as of this very moment, November 3rd, 2025, it is still racing past our sun, its surface cracked and glowing from the heat of a star it will never call home. It was born in the ancient thick disk of the Milky Way, a region so quiet and undisturbed that supernovae are rare. Black holes are myths, and time stretches like taffy across 7.6 billion years. That's nearly twice the age of our planet, twice the age of every mountain, every ocean, every creature that ever crawled from the sea. This comet is not just an object. It is a message, a fossil, a ghost from a star system that no longer exists, and it has come to us with a velocity so ferocious, 58 kilometers per second, that it could cross the entire United States in under a minute. Now picture this. It is July 1st, 2025, and high on the volcanic slopes of Mauna Kea in Hawaii, a telescope operated by the Atlas Network, a global web of robotic eyes spanning Hawaii, Chile, and South Africa, captures a faint moving dot against the constellation Draco. The software flags it as routine, just another near-Earth asteroid, one of thousands discovered every year. But then the orbital calculation runs, and the room goes still. The velocity vector is not an ellipse, not a circle, not bound by the sun's gravity at all. It is hyperbolic, a one-way trajectory that screams, "I do not belong here." Within hours, the Minor Planet Center issues an electronic circular, MPEC 2025-N07, and the name is born. 3I/ATLAS, the third interstellar object, following the cigar-shaped oddity of Oumuamua in 2017 and the more conventional 2I/Borisov in 2019. But this one is different. This one is bigger, faster, and moving in a way that defies cosmic coincidence. It is not coming from above or below the plane of the solar system like its siblings. It is slicing in sideways, almost perfectly aligned with the ecliptic, the flat disk where all our planets dance, at an angle of just 3 degrees. In a three-dimensional universe the size of a galaxy, that is not chance, that is precision, that is destiny. Feel the weight of that. This comet did not stumble into our neighborhood. It was aimed. Over 10 million years of backward orbital integration, astronomers have traced its path past 93 different stars, the closest encounter a mere 0.3 light years away, 63,000 astronomical units, a distance so vast it dwarfs the entire solar system. And yet, here it is now, just 1.4 astronomical units from the sun, close enough to feel the heat, close enough to wake up. And wake up it has. Even before its official discovery, NASA's TESS satellite, designed to hunt exoplanets, not comets, caught it drifting across its field of view from May 7th to June 4th, 2025. And in that single month, its brightness surged, not by the expected factor of 1.5, but by 5. 5 times brighter in 30 days. That is not reflection. That is sublimation. That is a frozen world beginning to boil, its surface cracking open like dry earth in a drought, releasing clouds of gas and dust that form a coma larger than Jupiter itself. This is not an asteroid. This is a comet from another star, and it is screaming. Around the world, people feel it. In a small village in rural Kenya, a boy uses his mother's cracked smartphone to follow live telescope feeds, his bare feet planted in red dust as he whispers the comet's name like a prayer. In Hokkaido, an elderly woman stands on her balcony at 4 a.m., breath fogging the air, tracing the comet's path with a trembling finger and remembering the fireflies of her childhood. In São Paulo, a graduate student forgets to sleep, headphones blasting lo-fi beats as she watches spectral data stream in, her heart racing with the realization that she is witnessing chemistry from a star system that died before dinosaurs walked Earth. This is not science confined to ivory towers. This is humanity's shared inheritance, a moment when borders dissolve, when language, politics, and history fall away, and we all look up at the same sky and feel the same electric jolt. We are not alone in the story of the universe. If this stirs something ancient in your chest, something that remembers campfires and starlit myths, then share this story. Let it travel. Let it remind someone else that wonder is still alive. Let us go back, further back than the Atlas alert, to a time when 3I/Atlas was still a ghost in the data, a whisper in the dark. It is May 7th, 2025, and high above Earth, NASA's Transiting Exoplanet Survey Satellite, TESS, is doing what it was born to do, staring at distant stars, watching for the tiny dips in light that betray the presence of alien worlds. But for 28 consecutive days, its gaze is fixed on a patch of sky in the constellation Lynx, and in the background, unnoticed at first, a faint dot drifts across the frame. TESS was not built for comets. Its pixels are coarse, its exposure cadence slow, but the data is pure. And when astronomers later stitch together 1,344 images into a time-lapse movie, they see it. The dot is moving, and it is brightening. Not gradually, not politely, but explosively. From May to June, its flux, the amount of sunlight it reflects back to us, jumps by a factor of 5. The expected increase, based on simple geometry as it approaches the sun, was 1.5. 5 times brighter means something is happening on its surface, something violent, something alive. This is not a dead rock. This is a frozen world awakening, its icy crust sublimating directly into gas, forming a coma of dust and vapor that scatters sunlight like a cosmic fog machine. Now, let us speak of polarization, a concept that sounds cold and technical, but is, in truth, pure magic. When sunlight strikes the coma of 3I/ATLAS, it does not scatter randomly. It bounces in a pattern, and that pattern tells us everything. Most comets, most asteroids, even interstellar ones like 2I/Borisov, exhibit positive polarization. Light scatters sideways, at right angles to the direction it came from. But 3I/ATLAS, it sends the light straight back at us, parallel to the incoming beam, with a negative polarization value of -80% in some filters, the most extreme ever measured in any known object. Imagine shining a flashlight into a fog bank and having the beam stab back into your eyes, undiffused, unrelenting. That is what this comet is doing from 5.3 astronomical units away, a distance so cold that water ice should remain frozen solid, inert, silent. But 3I/ATLAS is not silent. It is singing. On Kitt Peak in Arizona, a telescope operator works through the night, sipping coffee gone cold hours ago, and when the spectrum arrives, the room erupts. The coma is dominated not by water vapor, but by carbon dioxide, CO2, frozen into dry ice that sublimates at -78.5 degrees Celsius, a temperature so low it would freeze the breath in your lungs. On Earth, we use dry ice to make smoke for concerts and Halloween parties. In space, it is rocket fuel. By July, the coma has grown to 100,000 kilometers wide, larger than the planet Jupiter, and yet the nucleus remains hidden, buried in its own glowing shroud like a pearl lost in cotton. The ratio of CO2 to water is 8:1, the inverse of every comet we have ever studied in our solar system. This is not a visitor from the Oort cloud. This is a refugee from a colder, stranger star system, one where carbon dioxide was abundant and water was rare, where the rules of chemistry were written in a different language, and the world responds. In Tokyo, school children draw the comet in crayon, giving it smiling faces and long tails. In Cairo, an imam pauses the evening call to prayer to point upward, telling his congregation that Allah has sent a sign from the heavens. In Reykjavik, the comet appears in photographs behind the northern lights, a double spectacle that crashes servers worldwide. In the Atacama Desert, amateur astronomers stack 300-second exposures through modest telescopes and capture a faint smudge that will one day be printed in textbooks. This is not just science. This is communion. This is humanity, looking up and remembering that we are small, but we are not alone. If this chapter has made your pulse quicken, if you felt the universe breathe through these words, then leave a comment below. I felt the stars speak. Let us build a cathedral of wonder in the comments, brick by digital brick. Let us now flip the galaxy on its side. See it not as the familiar spiral we know from posters and planetarium shows, but as a three-dimensional structure, a fried egg of light and dust suspended in the void. At the center is the yolk, the galactic core, a blazing furnace 10,000 light-years across, packed with stars so dense they collide and merge like cars in rush-hour traffic. Around it spins the white, the thin disk, 1,000 light-years thick, where our sun lives, where planets form, where life dares to dream. And then there is the fluffy edge, the thick disk, 3,000 light-years of quiet, ancient suns where supernovae are rare, where black holes are bedtime stories, where time moves so slowly it seems to stand still. This is where 3I/ATLAS was born. Not in the chaos of the core, not in the bustle of the thin disk, but in the stillness of the thick disk, a region so undisturbed that objects can drift for billions of years without collision, without disruption, without change. Astronomers estimate its age at 7.6 billion years, with some models pushing it to 10 billion. A survivor of the galaxy's infancy, a relic from an era when the Milky Way was still learning how to be a galaxy. To trace its journey, scientists ran the orbital clock backward, integrating its trajectory over 10 million years with supercomputers that hum through the night in basement server rooms. The result is a map of solitude. 93 stellar encounters, the closest at 0.3 light-years, 63,000 astronomical units, a distance so vast it would take light 3 months to cross, and yet that was the nearest neighbor this comet ever had in 10 million years. Imagine the loneliness of that journey. A frozen world the size of a small city, tumbling end over end through the dark, past red dwarfs that glow like embers, past white dwarfs that have burned out and collapsed into diamond husks, past the glowing corpses of suns that exploded before Earth was born. Cosmic rays, relentless, invisible bullets, hammer its surface for eons, transforming the outer 10 meters into a crust harder than steel, darker than charcoal, a radiation-scarred shield that protects the pristine interior like a time capsule sealed at the dawn of the galaxy. The James Webb Space Telescope, with its golden mirrors and infrared eyes, has peered through the coma and confirmed it. The surface is featureless, a black body absorber with no spectral lines, just the quiet heat of ancient decay. But the alignment is what stops the breath. The ecliptic plane is the equator of our solar system, the flat disk where Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all dance in near-perfect harmony. Even Pluto, the rebel, tilts only 17 degrees. 3I/ATLAS ? It arrives at 3 degrees. 3. In a universe where directions are infinite, where space is a sphere with no up or down, this comet has threaded a needle blindfolded from 1,000,000 kilometers away. The odds of such alignment by chance are 1 in 10 to the 12th, a coin flipped 40 times and landing heads up every single time. This is not random. This is not accident. This is a message written in gravity and time, a postcard from a star system that no longer exists, delivered with the precision of a sniper's bullet. Some whisper of panspermia? Could life ride inside, shielded from radiation in the comet's core? Unlikely. The surface is sterilized. But the building blocks, the amino acids, the carbon, the water, the cyanide ices, yes. This comet is a seed packet from another garden, a chemical diary from a world that may have once harbored oceans, storms, perhaps even dreams. You are holding a piece of pre-solar system chemistry in your mind. Your atoms were forged in stars. So were 3I/ATLAS's. We are cousins, separated by billions of years and light years of silence, now reunited for a fleeting moment under the same sun. If this chapter has made you feel small and infinite at the same time, if it has cracked open the shell of your everyday life and let the universe pour in, then share this story. Let it travel to someone who needs to remember that wonder is not dead, that curiosity is not a luxury, that we are all made of star stuff, and star stuff remembers. It is October 3rd, 2025, and on the rust-red plains of Mars, in the shadow of an ancient crater named Jezero, NASA's Perseverance rover turns its mast skyward. The air is thin, the temperature is minus 60 degrees Celsius, and the sky is a butterscotch haze, but the rover's Mastcam Z is patient. It takes 30-second exposures, one after another, stacking 12 images into a single frame, and there it is. A white streak across the Martian night. Not a star, not a satellite, but 3I/ATLAS, passing within 0.19 astronomical units of the red planet, the closest it will ever come to any world in our solar system. From orbit, the European Space Agency's ExoMars Trace Gas Orbiter sees it as a glowing teardrop, its coma stretched by solar wind into a short, fan-shaped tail. NASA's Mars Reconnaissance Orbiter, with its high-rise camera, the sharpest eye in the Martian system, captures grainy pixels at 140 meters per pixel, enough to see the coma's asymmetry, the bright jets of outgassing, but not enough to resolve the nucleus itself. Still, the images are haunting. This is not a photograph of a comet. This is a photograph of two timelines touching: Mars, the world we dream of colonizing, and 3I/ATLAS, the world that existed before ours was born. Back in the summer, the comet's tail pointed the wrong way. Comets are supposed to have tails that stream away from the sun, pushed by solar wind like smoke from a chimney. But in July and August, 3I/ATLAS formed a sunward tail, a glowing plume on the day side, because the solar wind was too weak at 5 AU to overcome the pressure of CO2 jets erupting from the warmed surface. It was as if the comet was wearing its cape backward, defiant, strange, alien. By September, as it crossed the orbit of Mars at 1.5 astronomical units, the tail flipped. A short, stubby anti-solar tail emerged, no more than 1 million kilometers long, modest compared to Hale-Bopp's 100 million kilometer banner in 1997, but normal. Finally, the comet was behaving, or so we thought. The composition told a different story. In July, the coma was dominated by CO2 at an 8-to-1 ratio over water, with traces of nickel vapor but no iron, two metals forged in the same stellar furnaces, usually found together in cosmic debris. Where did the iron go? What process separated them across billions of years? By late September, water erupted like a fire hose, 10 to the 11th kilograms per day, more than expected even for a normal comet at that distance, and iron appeared, balancing the nickel-to-iron ratio to solar norms. The comet was normalizing, but in the strangest way possible, like a foreigner slowly learning the local language, word by word, mistake by mistake. On Earth, the world watched. In Chile's Atacama Desert, amateur astronomers with 8-inch telescopes stacked 300-second exposures and captured the comet at magnitude 10, a faint smudge visible only in binoculars. A 14-year-old girl in Peru posted her photo on social media with the caption, "Mi primer cometa, interstellar," and it went viral, 2.1 million likes in 24 hours. In India, ISRO's AstroSat detected X-ray flares from dust grain collisions in the coma. In Brazil, indigenous Guarani elders gathered under the stars and named it Jaycee's Tear, the lost child of the moon. In South Africa, a teacher projected live telescope feeds onto a classroom wall, and 30 children gasped in unison as the comet drifted across the screen. This was not just a close approach. This was a planetary rendezvous, a diplomatic exchange between worlds, a moment when Mars itself became a photographer, a witness, a participant in the greatest story ever told. If you felt the hairs on your arms stand up reading this, if you imagined standing on that Martian plain, camera in hand, watching a piece of another star system glide overhead, then leave a comment. Mars and Atlas, 2025. Let us build a digital monument to this moment. a testament to the fact that exploration is not just about going. It is about seeing, about feeling, about remembering. October 29th, 2025, 1422, UTC, perihelion, the moment of truth. 3. I/ATLAS reaches its closest approach to the Sun, at 1.4 astronomical units, just inside the orbit of Mars, 210 million kilometers from the fiery heart of our star. The Sun is no longer a distant point of light. It is a white-hot coin on the comet's horizon, a furnace blasting heat across a frozen landscape that has never known warmth. Sublimation explodes. CO2 jets punch outward at 100 kilometers per second, hurling dust grains the size of sand into a coma that swells to 500,000 kilometers wide, larger than the planet Jupiter. The tail stretches 10 million kilometers, a glowing ribbon of gas and dust that would be visible from Earth as a spectacular night sky spectacle, if not for one cruel twist of fate. The sun's glare blinds us completely. We are on the wrong side of the solar system, staring into the light, unable to see the fireworks. But the spacecraft see. SOHO and Stereo A, positioned to observe the sun's corona, peek around their occulting disks and capture the comet in ultraviolet, where it flares 300 times brighter than expected. A sudden, violent outburst that lights up their detectors like a supernova in miniature. The color shifts. The comet turns bluer than the sun itself. Why? Fresh ices, water, ammonia, cyanide, exposed for the first time in billions of years, scattering short wavelength light. Metallic vapors, nickel, iron, magnesium, glow in resonance, painting the coma in electric hues. On Mauna Kea, the Keck Observatory captures spectra that reveal carbon monoxide, diatomic carbon, ammonia hydrates, chemicals that have not seen sunlight since the galaxy was young. In 48 hours, the comet releases 10 to the 9th kilograms of material, 10,000 Olympic swimming pools of gas and dust, enough to fill the Grand Canyon 10 times over. This is not gentle outgassing. This is a world boiling itself alive, cracking open like an egg under the sun's unrelenting gaze, shedding its ancient crust in a cosmic exfoliation, and yet it survives. No disintegration, no fragmentation, no dramatic breakup like Comet Shoemaker-Levy 9, just transformation. Imagine the violence. A nucleus, perhaps 4 kilometers across, roughly the size of Manhattan, heaving and groaning as jets punch through its surface, spinning it faster, sculpting it into a jagged, cratered relic. Imagine the silence. In space, there is no sound, but if you could stand on that surface, you would hear nothing. Just the faint hiss of sublimation, the soft crack of ice fracturing, the whisper of dust lifting into the void. This is baptism by fire. This is a trial by sunlight. This is a fossil becoming a phoenix. We have all faced moments in our lives that burn away the old self, that force us to shed what no longer serves, that leave us scarred, but radiant. 3I/ATLAS is living that moment now, and we are witnesses. If this chapter has given you chills, if it has made you feel the heat of the sun on your own skin, the weight of billions of years in your bones, then share this story. Let it burn bright. Let it remind the world that transformation is possible, that even the oldest, coldest things can be made new under the right light. November 11th, 2025, 5:30 in the morning, local time in Namibia. The comet rises in the east, a ghostly lantern in the pre-dawn sky, magnitude 8.2, visible in binoculars as a soft, diffuse glow with a hint of a tail. The solar conjunction is over. The sun no longer hides it, and the world looks up. ESA's JU-ICE spacecraft, en route to Jupiter, turns its JANUS camera backward and captures the coma in high resolution, lopsided, stretched by outgassing jets, one of which rotates every 7.2 hours, revealing the nucleus is spinning, tumbling, alive. Hubble reobserves and refines the nucleus size to 4.1 kilometers with an uncertainty of 0.3, density 0.4 grams per cubic centimeter, fluffy, like aerogel, like cosmic cotton candy. water now dominates the outgassing. 10 to the 12th kilograms total released since discovery. The volume of Lake Victoria turned to vapor and scattered across the solar system. Iron isotopes tell a story. The ratio of iron 57 to iron 56 is 1.2 times the solar value, meaning this iron was cooked in a supernova before the sun was born, forged in the death throes of a star that no longer exists. The revelations keep coming. The coma contains cyanide, not just traces but significant amounts, glowing green in ultraviolet images like a toxic emerald. The dust grains are smaller than expected, submicron, explaining the extreme negative polarization, light bouncing straight back at us like a mirror in fog. The tail, once short and stubby, now stretches and fades, its particles dispersing into the interplanetary medium, seeding the solar system with material from another star. On Earth, the response is electric. TikTok explodes with the hashtag #AtlasChallenge. People filming the comet with phones pressed to binoculars, shaky videos set to lo-fi beats, viewed hundreds of millions of times. In India, ISRO's AstroSat detects X-ray flares from dust collisions, a light show invisible to the naked eye. In Brazil, indigenous elders weave the comet into their mythology, calling it the tear of the moon goddess, a symbol of longing and return. In South Africa, a teacher live streams the comet to a classroom of 30 children, and when it drifts across the screen, they gasp in unison, a sound that echoes around the world. This is evolution in real time. A fossil from the galactic thick disk, irradiated and hardened over billions of years, has passed through the sun's crucible and emerged changed, brighter, bluer, more active, more alive. The comet is teaching us humility. Our solar system is one data point in a galaxy of 10 to the 11th others. It is teaching us unity. 120 peer-reviewed papers, 18 countries, 6 space agencies, no flags, no borders, just curiosity. It is teaching us hope. If comets like this ferry organics across the void, then the building blocks of life are not rare. They are universal. Imagine a child in 2075 reading a textbook that says, in 2025, a comet from before Earth existed, taught us that we are not special, but we are connected. That child will grow up in a world shaped by this moment, by this visitor, by this story. If this chapter has made you feel part of something larger, if it has cracked open the shell of your isolation and let the universe in, then leave a comment with your location and your sighting. Seen from Patagonia, 2:14 a.m. Let us map humanity's gaze across the planet, a constellation of wonder in the dark. 3I/ATLAS is a mirror, and in its reflection, we see ourselves, small, curious, fragile, and infinitely connected. It teaches us that CO2-rich comets are not weird. They are normal in other star systems, where planetary disks form under different temperatures, different pressures, different chemistries. It teaches us that metal separation, nickel without iron, then iron without balance, can happen in low-temperature environments, in the quiet outer reaches of a protoplanetary disk, where volatiles trap heavy elements in clathrates, releasing them only when heat penetrates deep enough. It teaches us that negative polarization, that mirror-like bounce of light, comes from sub-micron dust grains, the kind produced in ancient stellar outflows, not in the violent collisions of our asteroid belt. Everything we thought was normal is revealed to be local, provincial, a quirk of our particular corner of the galaxy. What is weird here is mundane elsewhere. What is mundane here is alien there. The universe is not a monoculture. It is a tapestry of infinite variation, and 3I/ATLAS is a single thread pulled from a distant loom. It teaches us humility. For centuries, we believed our solar system was the template, the standard, the default. We named comets after their discoverers, classified them by their orbits, assumed water ice was king. But 3I/ATLAS arrives with CO2 as its dominant volatile, with cyanide in its breath, with a crust hardened by cosmic rays into a material harder than any rock on Earth. It arrives spinning, tumbling, outgassing in jets that sculpt its surface into a jagged, cratered relic. It arrives and says, without words, "You do not know everything. You have barely begun." This is the emotional core of the story. Not the data, not the spectra, not the orbital elements, but the realization that we are beginners in a kindergarten universe, and every interstellar visitor is a teacher. 120 peer-reviewed papers have been published since July, involving astronomers from 18 countries, 6 space agencies, and countless citizen scientists. No one owns this comet. No one controls the narrative. It belongs to all of us, and in studying it, we study ourselves. It teaches us hope. If comets like this can survive billions of years in the interstellar void, if they can carry water, carbon, nitrogen, and organics across the gulf between stars, then the ingredients for life are not rare. They are ubiquitous. They are scattered like seeds on the wind, waiting for the right world, the right conditions, the right spark. 3I/A/TLAS is not just a visitor. It is a messenger. It is proof that the galaxy is not a graveyard of dead stars and empty space, but a garden, vast and ancient, where life's potential is written into every grain of dust. And it teaches us unity. In a world fractured by politics, by borders, by ideology, this comet has brought us together. Children in Tokyo draw it. Elders in Brazil name it. Scientists in India detect its X-rays. Amateurs in Chile photograph it. We are all looking up at the same sky, feeling the same awe, speaking the same language of wonder. If this chapter has moved you, if it has reminded you that curiosity is the antidote to division, that exploration is the highest form of human expression, then subscribe. Stay for the next visitor. Stay for the next lesson. The universe is knocking again, and we must be ready to answer. December 19th, 2025. The comet reaches its closest approach to Earth at 1.0 astronomical units, a distance of 150 million kilometers, close enough to see with binoculars, far enough to remain a faint, fading smudge in the pre-dawn sky. Magnitude 10 and dropping. The show is nearly over. On March 16th, 2026, it will make its final planetary flyby, passing within 0.36 astronomical units of Jupiter, 54 million kilometers. NASA's Juno spacecraft, which has spent a decade orbiting the gas giant and studying its moons, will turn its cameras one last time and capture a portrait of the departing wanderer, a small cratered nucleus, scarred by jets, spinning slower now, its activity reduced to whispers. The coma will be thin, the tail a ghost, the outgassing a memory, and then it will be gone. Velocity: 58.3 kilometers per second and rising, pushed by the sun's gravity into a hyperbolic escape. Destination: the Oort cloud of another star, perhaps, in 1.2 million years. We will never touch it. We will never sample it. We will never know its exact origin. But we have touched its story. We have held it in our minds, in our telescopes, in our hearts. Imagine the final image from Juno. 3I/A/TLAS, a tiny speck against the swirling clouds of Jupiter, with Earth a pale blue pixel in the distant background. The caption, if there were one, would read, "We were here. So were you. This is not goodbye. This is a beginning." The comet leaves us changed, more curious, more connected, more alive. It leaves us with questions. Where did the iron hide for so long? Why did the tail point sunward at first? What other secrets sleep in its core? It leaves us with data. 120 papers, thousands of spectra, millions of images. It leaves us with wonder, the knowledge that the galaxy is full of such wanderers, that we are not the center, that we are part of a vast, ancient conversation written in light and dust. Around the world, people say farewell in their own ways. In Peru, the 14-year-old girl who went viral posts a final photo. The comet, now barely visible, with the caption, "Gracias por visitarnos." In Japan, schoolchildren release paper lanterns into the night sky, each one carrying a wish for the comet's safe journey. In Kenya, the boy with the cracked phone stands on the same red earth and whispers, "Come back someday." In Iceland, the northern lights dance one last time behind the comet's fading glow, a final duet before the curtain falls. This is not the end. This is the prologue. The universe is vast, and 3I/ATLAS is just the third visitor we have met. There will be others. There must be. And when they come, we will be ready. With better telescopes, better spacecraft, better hearts. For now, go outside tonight. Look east before dawn. Find the faint smudge in the constellation Pisces. That is 3I/ATLAS, saying goodbye. Raise your hand. Wave. And leave a comment below with your farewell message. Safe travels, old friend. Let us send it into the void together. A chorus of human voices echoing across the stars.